Hello, I'm Sharir Papon, and I'll be going over Lab 3 here for class EEE-120. Um, so in the Lab 3, the main thing that we built was the brainless CPU, and we used a bunch of the components we built in the other labs, especially in Lab 2. I think we built the multiplexer, the full adder was in Lab 1, I believe. But yeah, essentially we used all the previous components. And here, the first question asks us to build a 4-bit deregister, and we use the built-in, or you call it the wire splitters. Yeah, we use the wire splitters to split all the inputs. One of the problems that I was having with this circuit, let me go into the screenshot here. One of the problems I was having with this circuit it was giving me an error whenever I tried to simulate it, like an elaboration error. That was potentially tied to this D input being set to like I believe like 2 bits or something, and I had to change that. Yeah, and here's the waves. I do have pictures of the waves as well. Here it is, and we can see all the inputs here. See, okay, D enable, and that's the output Q. So the second question asks us to build a 4-bit up counter. Now this was actually pretty simple. You can see there aren't many connections at all, and especially because we created the 4-bit register already and the incrementer, like we really didn't have to do much. So if I go into the, I guess I don't have a screenshot, or maybe a program counter screenshot. Here we go. Yeah, and one of the things that we used here that I didn't use before was the supply, this power supply type of thing. And yeah, and here's the inputs and the output. I also had problems with this output being like 1 bit, and then I had to keep coming back, change it to 4-bit, blah blah blah. But yeah, a lot of errors, because I guess the more you like stack on like older components, the more chances are there to be errors. The next question was create a 4-bit RAM with the 16-bit 4-bit words. This was also pretty simple because we already have the diagram here. We can go to the, let's see, I thought I had a screenshot of this, suppose not. But yeah, we can see it here. And then we build a test brainless central processing unit, so it's like a brainless CPU, right? So if we go into this brainless CPU, where is it? Brainless, there we go. Yeah, so this was the most complicated circuit we built here. I mean, obviously this is the ultimate goal of building all the logic gates to arrive at a CPU processing unit, right? We use like a lot of the older components like the ALU, 4-bit register, 4-bit multiplexer, program RAM, and 4-bit mux. We also created this program RAM, and we also had to label these 4-bit muxes because there's 2 of them, and it might get confusing whenever we're in Verilog or the .v files. And we have the outputs ALU out and accumulate. Let's see. Yeah, this is the image. And also here the CN goes to ground, which I found kind of interesting. I'm actually not sure where the CN goes to ground, but it does. But yeah, that was pretty much it until we got to the end, and we had to create these 3 test files for write, read, and brainless ALU, and basically run them both using iVerilog and run the timing diagrams here. So yeah, that was pretty much it. I didn't really have any problems with these because the instructions were pretty clear. All I had to do was I think change some of the input bits to 4, because some of them are still set to 1, and set one of the circuits width to 9 as instructed. But yeah, that was it. Thank you for watching. Yeah.